All right, this is another video on list comprehensions. I'm going to dig further into some use cases that you might find helpful to go through that you might encounter at work. Basically, we're going to transform a two-dimensional list of numbers into two separate things. One, a flat list of numbers, and the other one is into a separate two-dimensional list of numbers where the sublists are filtered. So I think these are sort of common use cases in terms of transforming data. Let's take a look at what we have. So we have a list of lists of numbers. The first thing I'd like to do before I cover these use cases is to go over rewriting a list using a list comprehension. So let's say we have a list of numbers, 1, 2, 3, 4. We can write a new list like this. N for N in old list. And these are not the same item. There's not the same object, but they are equivalent. So they contain the same elements. And I'll print that out to verify. So here we have 1, 2, 3, 4, 1, 2, 3, 4. So keep this in mind. It's going to be useful when it comes time to do some filtering in our list comprehension in the following cases. All right, so flatten the list. So what we need to do here is go through every row and take out each item. So we need to go through the data on the row level and on the item level. I usually like to do the for loops in a list comprehension first. And just to remind you, a list comprehension up front, you say what you want. And that what follows that is a sequence of for loops, which tell the thing how to iterate through the structure. So I'm going to start with the for loops just because it helps me kind of visualize what I'm doing here. So I'm going to say for row in data, that means we're going through the data on the row level. For item in row, and I want that item back. So I'm going to print this out to verify. I should be getting the original data set, but as a flat array. Let's see what we get. That looks right to me, 1 through 16. Okay, so the tricky part comes when you want to, let's say, filter the flattened list. I'm going to approach it using a nested list comprehension so that we can really get our hands dirty with list comprehensions. So you might want to say item if item is greater than 2. For example, like say you only want numbers that are greater than 2. And that is not syntactically valid because this original list comprehension expression always needs to return a value. And this if item is greater than 2 doesn't return a value unless you add an else clause. And then it doesn't really make sense to return something regardless. We actually just want to filter the data set down to a smaller data set. So instead of putting this if here, which won't work, we're going to have to turn either data or row into its own list comprehension and filter that way. And we can turn it into its own list comprehension by using this method here. Right? So let's take a look at what we might want to do. So we can do it on row by substituting row for n in row. Let's print that just to make sure we don't have anything we don't expect. Okay, 1 through 16. Right, so now we can throw the if statement here at the end, because when you throw an if statement in, as a part of a for loop at the end, that's actually not expected to return a value. That's to tell the list comprehension whether to keep the value or not. So these are two different cases. Up here has to return a value, but at the end of a for loop inside, or the for expression, you don't need to return a value. And that's actually not the point of the if. The if is to say, do I keep it or not? So it's like a filtering mechanism. So let's see if this works to keep only numbers that are greater than 2. So we should have basically 3 through 16. All right. Flatten data returns a flat list of numbers from 3 to 16. Cool. Now, the second case is going to be one in which we take the source data and turn it into, make a copy of it that has the same shape. So it's a list of lists, and those sublists will contain the same elements, excluding the ones that are fewer or equal to 2. So anything that's 3 and above gets kept, and any other ones are totally ditched. So we'll say the first step to think about is, let's go look at the original data. Since we have a list of lists and the comprehension is doing this part of it, so it's returning what's inside of the resulting list, we are returning rows. So that's important to think about. What level do we need to traverse into data in order to return rows? Do we want to look at the individual items? I would argue here we don't. Okay, so for row in data, we want to return a row. So let's see. I'm going to print that out just to verify that what we see here should be the same as the source data in terms of the values and the structure. Okay. List of lists, each one has 4 numbers, and it goes 1 through 16. So that's what I'd expect there. Now I'm going to do a substitution here, and this should also print the same thing. And it looks identical. But this substitution allows us to throw the if statement at the end and thus remove elements from the row that's returned. And notice what's being returned here has no if on the expression level. The if is included inside of the comprehension, which comes at the end of the for loop, or the for expression there. So that's legal. Okay, so in the transform data, it's pretty close to what we started with, but as you'll notice, the first sublist does not have 1 and 2 because those failed this if n is greater than 2 test. So these are 2 ways to transform data. One keeps the structure intact, and the other one just flattens it into a single dimensional list. The last thing I'll do is I will make this a little nicer to read so that the person who comes across it doesn't have to do as much work to figure out what you were doing. We're going to show our intention here by writing some utility functions, or maybe just one, I think. So let's do okay, so what I'm going to do here is, instead of n being greater than 2, which is just something I arbitrarily chose at the moment, I'm going to really do I'm going to return only even numbers instead, just so that it shows you more drastically the filtering operation we're doing. So I will say, so ns will be basically ends is what I mean by that. And that's going to be a list of numbers. And I'm going to move this list comprehension, which is effectively a nested list comprehension. I'm going to move that out of the main list comprehension and into our utility function. Okay. So get evens takes a list of numbers n's and then transforms that into a list of n's that are not greater than 2. I'm going to say they're even. So anything that's even returns true. And so we can take this flattened data list comprehension and we can say get evens on the row. And we can take this transformed data list comprehension and we can say get evens on row. In both cases, we're passing the row into this function, and then what's returned is a subset of that row, or like a limited version where only the even ones are returned. And let's just, before I talk about this further, let's just verify that it works. And I'll print the flattened data and the transformed data. Okay, the flattened data, it's a flat list of even numbers from 2 to 16, and then the transformed data is a two-dimensional list, and it has even numbers in the sublists as we'd expect. So this looks like it works. My final comment is, how nice is this to read, right? Item for row and data for item in get evens from the row. Transform data is get evens from the row for each row and data. They read really well if you use utility functions. So I hope that that helped you understand how to work with a source data set and transform it into something that fits your use case. This is often the case what we're doing at work. We're taking data sets and flattening them, deduplicating them, filtering them in some way so as to be useful for, I don't know, reporting or displaying in a UI or whatever. So anyway, I hope that was helpful. Stay tuned for more videos from me. I'll see you in the next one.